All right, welcome everybody to week 4, day 1 of everyone's favorite game development class, IS50A. Today we are going to start talking about materials a little bit. I did get some questions about timers, so I think I'm going to go over timers a little bit more. I did kind of just touch on them briefly. I did say they're kind of more of an advanced topic. I usually don't cover them on week 3, but, you know, it was asked, and if you guys ask me to show you something, I'll show it to you. Okay, so let's say we wanted to make a, let's say we want to make like a race, you know, where like maybe, you know, they walk inside of here, it starts a timer, and they're given 20 seconds to walk to here on the top of the platform, something like that. This is a fairly common thing that students do as like their final project, some sort of like platforming game. They just slap a lot of boxes in the world, and you have to like jump from it within a time limit. So let's go over that. Couple different ways we can do it. I guess we can just start off by just putting a trigger box here and kind of put it up here, and like kind of like shaping it to match the start zone of the yeah. Basically, when the player walks over this, it's kind of that's a little too wide, I guess. So, you know, the player kind of walks into this area, then we're going to start like a 20-second timer, and maybe they've got to like run over this way, come up here, and then like jump over to here, and like we can get rid of this thing, I think, right? This, which just says bruh every time. It's confusing. Okay, so that'll be our starting zone, and then we'll have like an ending zone, like over here somewhere. So, trigger box over here. A little bit. Snap it down. Widen it out. I don't want it sticking out over the lip like that because then the user could just. It's a little bit too wide. A little bit. And yeah, split up a little bit too as well. And snap it down. So basically, you guys got the idea. So you're gonna start off here. They're walking, and they got to run like up here, and then enter the zone here. Do you guys get it? Like the purpose? We haven't done any code yet, but like, do you understand the concept? Okay. So we're gonna click on this thing here, and we're gonna click on the details tab. Remember, world settings kind of gets in the way of details. Sometimes the students are like, "Where's my stuff?" You know. So if you see world settings, click on details instead. And then we're going to click on the little flowchart looking thing there, click on that, and we're going to turn it into a timer start zone. And we're going to save it in the build directory, or whatever your name is. And then we have a little preview here of it. We're going to go over to the event graph. And basically, all we need to do is say that when somebody enters the zone, if that's the player, then start a timer on them. And so, yeah. So we're just going to do our check, which is cast to third person character. That's our check to see if the person who touched us is the main character. And if they are, then we're going to do something. So, different ways we can do this. In fact, the easiest way actually involves not having a timer. Do you want to see the easier way first? That doesn't involve a timer. Timers are used for repeating events, and technically, when you touch the thing, you don't need to repeat it ever, right? So, okay. You want to see the timer? Yeah, I kind of want to show you the timer so you can see how timers work. Maybe we could do something where it's like every couple seconds, it's like playing like a sound like, you know, hurry up or something like that. But let me show you the simpler way first, and then I'll kind of hack a timer on top of it. So when the person touches us, if they are the main player, we are going to probably set a variable on them, so we need to go over to the person, BP, third person character, and we need to make some sort of variable. Probably float, I'd say. And we'll call this one like start race time. I don't know. I hate naming variables. And start race time is going to be a float because time is a float, and we're going to make it public. So where did it go? Start race time there, and we're going to make it public there. And so that means that other blueprints are going to be able to edit it. Okay. So compile it, save it. If you don't do that, it won't appear over here. And don't forget to compile and save. It's just every time. And so we're going to drag off the blue pin. Don't drag off the white pin. Drag off the blue pin. And we're going to set start race time just to the current time. They're not quite lined up. They're like 2 pixels off. Okay, and so we're going to set the start race time to the current time. So we're going to get time. Let's see, get world time, get actor time, get game time since creation. That works. Okay. No. Get time. So many different get times. Get accumulated time. Get delta time. Sorry, your Alte, my power. Get accurate real time. Get real time in seconds. Get game time in seconds. I think is the one we're looking for here. Okay. There's different options. Like you can make it so there's time dilation, so the time goes slower for like bullet time, dodging things like in the Matrix. You can pause the game and then game time pauses. And I think that's probably the one that we're looking for here. Get game time in seconds. We're going to set that on the player. And then also I'm going to delete the zone. Because basically because otherwise you could walk back in there and reset the clock, which maybe you want to do, but I don't know. Maybe you do, but maybe you get to have a second crack at the race. But for now, I'm just going to remove the zone. It kind of makes sense to me. Like once it starts, that's it. You know, you gotta do it. So that when the player touches the zone, here, it's going to set a variable on the player that is the current game time, and then it deletes itself. And so if we run it right now, you're not going to see a whole lot, right? Like it's just going to you can't even tell, right? So we probably should put a print string on here, but I'm just going to assume all this works, which is a bad habit to get into. Okay, so so we could just add something to the heads up display. Yeah, that might be the easiest way of doing this without doing a timer. So we got our stamina bar widget. I'm going to open that back up, and we're going to have, we're maybe going to change this thing here. So right now it says mission survive. And if you touch that zone, I want to change the quest to, mission, navigate the obstacle course, time remaining, blah. Okay. So we can do that by binding the text. Okay. So remember how we bound the progress bars last time? We're going to do the same thing for the text here. And so basically every frame, it's going to update the text here. And so we're going to bind, create binding, and it makes a function over here called, I don't know, I'm going to call it get quest text, something like that. And so there's 2 things that we need to worry about. One is, what if they've never started the race? If they've never started the race, start race time defaults to 0. What if they touch it at time 0? I'm not going to worry about that. I could set it to like -1. Maybe. Yeah, maybe. Yeah. Okay. So it's going to default to -1, which is impossible. It's impossible. You can't have -1 time. So that means we've never started the race ever. So just in case we spawn the player inside of the starting zone, I want to kind of handle that case. It's probably not a big concern, but this is what I'm going to do. So we are going to we already made a variable for the main character. Nice. Okay, so drag that out, get main character, and we are going to get start race time. And I'm gonna line these up. Okay. And so what I want to do is there's two options. If we've never started the race, I just want to print to the screen mission survive. If they have started the race, then I want to print how many seconds are remaining in the race. So I'm getting the race time here, so I'm going to drag that into a branch like so. And now let me turn the RGB. Sorry, the RGB lights on my keyboard turn off sometimes, and so because they're synced to the background, and the wallpaper engine doesn't run when I've got a full screen app up. So if I flip it like that, then it turns my keyboard on, makes it a little easier to see my keys. So it's just a little gamer bling right there. You know what I mean? All right. Gotta have the Corsair MX Cherry MX Browns, which are a really nice key. I really like. Okay, so we're gonna drag this up and do a branch. Actually, we're gonna compare this with -1. So if this equals less, we'll just do less than. So if the start time is less than 0, then we will turn that into a branch like that. So if they have never touched start, display mission survive. So the return value here is just going to be mission survive. I hope you guys get the meme-ish reference there. You can actually have different return nodes. Like, you don't have to do anything special. So if the time is less than 0, then we do that. Otherwise, and we can just hit that, Control D duplicates. Otherwise, what we're going to display is get game time in seconds. So we're going to get the game time in seconds, and we are going to, let's see. So the players start race time plus, we should probably set a variable for them called like race duration or something like that. And we'll make that public as well. Compile, save, and I'm going to set race duration to be 20 seconds. I could hard code it at 20 seconds, but I don't like hard coding things like that. So I'm going to grab off get race duration. Like I said, I could just make this 20 seconds, but I'm going to do it properly. So we're going to just grab 20 seconds here. Okay, so we're going to get the start race time. We're going to add 20 seconds to it. And so, like, let's say the race began at time 10. Then they have till time 30 to finish. And so we're going to take 30 and subtract the current time, which might be like 15. And it'll be like 15 seconds remain. Okay, so we're going to take this and subtract out the current time. This. And then the result, we will just... We could just display that, and it's going to cast that for us. So we'll just display that for now and just show you what that looks like. Okay. So mission survive, mission survive. We walk in here. Oh, it did not work. Why did it not work? Oh, because I didn't link it up. There we go. Classic blunder. All right. Let's try that again. There we go. All right. So you can see the timer's counting down. Naturally, we don't have our end zone set up, so you see it's kind of flickering a little bit because as it changes in significant digits, it kind of it's centering itself, and so it looks a little awkward. We probably should round this to the nearest number, and then also when we hit negative, it doesn't do anything, right? So, but there we go. Good start. don't forget to connect the things up. Okay. That's, yeah. Yeah, we all do it. Why is it not doing anything? Oh, you didn't connect it. Okay. We should probably append a string to it saying time remaining. And so there is something here called append. What are you? You are a text. Okay, so let's see. Cast to string. Do you work to. Text. Text is weird. What we want is a string, really, not a text. Text are things that kind of get displayed. And then that we are going to append. There we go. Yeah, for whatever reason, like you can append things which glues two different strings together. You can append things on a string, but not on a text, because the text is kind of like a display object. So if you, always on top's getting ignored, of course. Weird. Or this guy's set to always on top somehow. Oh. Wow. And I need to see my face. Okay, so we're going to append to this the string time remaining, and then the output of this we're going to drop into there, and it converts from a string to a text. And so that's kind of how you have to do it if you want to make that look good. So there you go, time remaining. You can see it's flickering. Again, we have that issue with the rounding. So before we do all this, we're going to round it. Actually, we're going to say floor. Floor, so if it's like 19.5, then it'll be 19. What's going on here? Are you crashing? It's going to make our thing look a little bit nicer, I think. Look at all that spaghetti. Okay. So floor is going to round it down. So 19, 18, right? I could have rounded it to the nearest, maybe, but this will at least give you like that one last second, right? Time remaining, gonna be like 0. Watch. See, then you lose. Okay, I kind of like that just because it gives you kind of like a last second, to do it. If you want, you could have rounded it instead of floored it. So, yeah, that's basically that. Because I'm not showing the decimals anymore, I don't have to worry about that weird flickering as significant digits change things. Sliding left and right, it's going to look pretty good, I think. How do you make a kill screen where it looks like when you run out, you died? Okay. Can somebody make a kill screen for me? I'll throw that out to the chat. So if anybody, just find one on Google Images or, make one on MS Paint, something like that. I'm not an artist. If you make one for me, though, I will very happily, add your kill screen to the game. You're not an artist? Oh. Yeah. Somebody post something, and I'll show you how to do that. Okay, so that is how to do this without using a timer. Okay, so what we did here was we basically just set a variable, and then, just the HUD will just kind of update in real time. We need to do the end zone, right, where like Windows blue screen. We need to do the other end, right? Because right now we can start it, but we can't actually. We're not doing anything to be finished. So what we need to do is double click to zoom over there. So this we need to convert into a zone. So the other guy was called timer start zone. This will be called timer end zone. And this will also be in game bill. And for this, we don't need begin play. We don't need event tick. Basically, we're going to do the same thing as before. Cast to third person character. Like that. Just like that up like that. And so if the player walks over the zone here, then basically, I don't know, like play like victory music or something, like some sort of like Final Fantasy fanfare or something like that. I don't know, like, but we also have to check to make sure they got there on time, right? So like, if they got there within the time limit, then like go, and show fireworks or give them a point or I don't know, something. So you died. That's perfect. Yeah, I like that. All right. So that is your classic Dark Souls. Oops. Yeah, Unreal Engine is just choosing to be on top. Yeah, there we go. Okay. All right, so we'll save this, and this will just be like Dead Souls. I don't know. Okay. So yeah, I guess we can do that before we do the timer end zone. So, yeah, timer start zones up there, timer end zones up there. Okay, so let's do the death. Okay, so if we ever hit negative time remaining, then I guess I guess I guess our HUD. I really don't want to do it here, but I guess our HUD code could do it. So mission 5. All right, where's our stuff? I guess we could kill the player here. This is really not the right place to kill the player, but I guess it would work. So we can throw another branch in here. So we're gonna compare this to less than 0. So dead. Okay. So we'll slap another branch here. And so if dead is false, we'll do that. If dead is true, then we will I guess just display the game over screen. I mean, there's more that we could do on that, but okay. So let's go back to the designer here, and let's add a image like this, and we will anchor it to the center of the screen. That, and the offset will be 0, 0, and the image will be open image. Oh, no, that's launching Visual Studio. Oh dear. This little maneuver is going to set us back 100 years. Oh dear. Yeah, I'll just ignore that for now. Where are you? Loading Visual Studio. No. Alright, well, oh gosh, I can't click on anything. It's so terrible. Alright, Visual Studio. Alright, any questions while this is loading? So do you understand what we're doing? Like we walk into the zone, we save the current time, and then every frame we're just updating the HUD based on how much time is remaining. We're doing a little bit of math, current time plus this minus this. You know, it's doing a little bit of math, figuring out how much time remains. And Visual Studio, please stop sucking. Yeah, just close. I don't care. No, don't report the problem. It's fine. Okay, there we go. Okay, so what was I going to do? I was going to import into here, Dead Souls. There we go, and save, and stamina bar, compile, save. Okay, so you are going to be image. There you are. Oh, it's right there. Okay, easy. It's really small, so let's make it a little bigger. Alignment. Where is it? Oh, that's cool. Tint, image size, alignment. I really want this set to be centered. I don't know why. Okay, we'll make this like 640 by 480 and set this to negative 320. It's kind of annoying. Negative 240, and there we go. Centered on the screen. And so by default, this thing is going to be not enabled. Actually, enable is fine. Visibility is hidden like that. And so if we run the game, it doesn't appear. All right. But if we ever hit 0 seconds, then image 0, rename this. Image 0, this is going to be called dead. Dead image. Okay. So if we ever hit 0, then we are going to set its visibility to show. And okay. So if we ever hit 0 seconds, then dead image is going to set visibility to be visible. You see what's happening here? So if the amount of time remaining is less than 0, then we show the dead image. And we're not actually reloading the map or anything like that. And again, this is not exactly the right place to do that. But it'll annoy them enough they'll start over maybe. Do that. So we got time remaining. It's counting down by seconds again. And no, why is the end zone not working? Who made this buggy game? Sprint. I ran out of stamina. You died. All right. So there you go. That's as simple as I can make it. I guess we can just fill up the entire screen if we really wanted. And then, you know, we could like fade it in. You can adjust the Z order of the thing so that it so then it doesn't matter if they're still playing the game, they can't see anything. But technically, we should like pause the game and like reload the map or whatever. But I'm not really too interested in the game over screen right now. Okay. The trouble with this is that if you do this, then you can't see the rest of your your HUD. So it's usually better to do a separate widget for the game over screen. There's an option to like hide it, and the thing here. So you do that sometimes where like you just don't draw it in the HUD. Opacity. Let's do opacity of 0. Yeah, this is a better way of doing it. Okay, so we have opacity of 0, and then it's not going to cover up our thing, and then come over here. We set it visible, and also we set its opacity. Set opacity to be 1. Not 10, 1. Thank you. So now at least we can still work on our HUD without the screen blocking everything. Okay. Changes the index of the UDITE image. You could, but then it would draw the health and stamina over it on the dead screen. So I actually do want it covering up all of the elements on the screen. And there we go. Oh, yeah, I should probably have it cover the whole screen. Then. Still see the corner over there. Whatever. I don't care. All right. So what would be better to use if you want the timer to start with a pick up the item in the house? This way works. It would work exactly the same if you pick up the vaccine and you have like 20 seconds or whatever to do it. Except instead of it being on a begin overlap, it would be the I'll save this. It would be on the thing here, which is currently called Corner Frame Blueprint, which I'm going to change the name of to Vaccine BP. So I know what it is. And so here, rather than just setting the variable, you could like set, like basically do that. Like you just set the timer there. And then the thing could all basically work like that. Okay. This is kind of garbage code, at least in terms of layout. Spaghetti. Yeah. I'll screenshot all of it for you. Oops. Try that again. Screenshot. There you go. So I wouldn't recommend admiring this for its beauty, but it works. So, there you go. So basically, the first thing we check is if they've never hit the start zone. It just says mission survived. If they have set it, then we calculate how much time there is remaining. If the time remaining is less than 0, they're dead, and we do the game over screen and make it not transparent anymore. If there is time remaining, then we show time remaining and do that. Now, the last thing we need to do is stop it. Okay, so if they touch the end zone, then I guess we could just stop the timer. Like that's probably the easiest way of doing it. So we could set time start race time. We just set start race time to like -1. And just call it a day because there's kind of more stuff I want to get onto than this. So basically, if there you go, you got time remaining, you got to do the race. In reality, there we go, mission survive, right? In reality, I do fireworks and a sound and but whatever, you know how to do all that stuff. I'm not gonna waste any more time on this. So if you wanted to do this with a timer, so perhaps you wanted to spawn a timer and you want the timers to cause something to happen every so often, we can do that. So maybe over here we could like set event timer. So you can create what's called a timer handle structure. And that like holds your timer. So when you call set timer, you can save it, and then that allows you to like pause it and like resume it and destroy it and things like that later on. So like let's say we want timer start zone to start the timer. So I'm gonna delete this here, but I used it to create the right type because I can never remember the right type for these things. There's just a lot of types in Unreal Engine. So I'm going to call this variable reminder timer. Okay, and it's going to be public so that other blueprints can edit it. And so what I'm going to do is when you touch the start zone, not only are we going to start the race time, but we are going to set a timer by event. And the event, ooh, I don't know if we can do this actually. Yeah, maybe this is a bad idea. Probably because we're about to destroy ourselves, so we can't have any events on ourselves because we're about to destroy it. Yeah, I'm just going to leave it like this. Let me just give you a different example of using timer. Okay. So like here when we begin playing, we create a timer 100 times a second. It's going to fire this event here. Okay. And if we wanted to stop it from running, I don't remember what the command was. It was like invalidate, clear and invalidate timer by handle. Like if you want to stop a timer, that's what you use. Yeah, you can create a custom event and then have a timer call that event every so often. You can have it, if you don't loop it, it'll happen once. And that's very useful for things like grenades. So like you throw a grenade and then you set a timer saying 3 seconds, call a grenade explode. And yeah, spaghetti, thank you. Yeah, probably because it doesn't make sense to me philosophically to have the start zone periodically like do something to the player, because all it really needs to do is activate once. You walk into the start zone, it starts a stopwatch, that's it. Like it doesn't really like make sense to me to have the start zone repeatedly doing something to the player. Like it just needs to activate once and call it. Okay. And then timer end zone, yeah, it ends the race. We could delete ourselves, I guess. We wanted to, I guess. Delete actor, distractor. I guess we can do that. It's not going to matter. Okay, so that is, we're going to sort of pause our discussion of coding now. So you've got kind of enough knowledge to code kind of anything in Unreal Engine. You know about how to have things happen if you touch them, how to have things happen if you overlap them, how to have things happen repeatedly with a timer, or after delay with a timer, have things happen every frame. You can have things happen when you hit the keyboard or the mouse. You know how to do hit scan, you know how to do projectiles, and you know how to do everything with enemies except for having them actually walk around the map. And that's going to be not today, because today I actually want to get to materials. So materials are art. And so like I said, we're going to shift gears, we're going to turn off the programming side of things right now, and we're going to get into the art side of things. So we've got this giant white building here, which looks very impressive. It's very postmodern, clean, and stuff like that. We got this green landscape that's sort of this undifferentiated green, kind of thing. And all of these things have on them things called materials. So materials is the surface. So you can see here on this chrome material, it's kind of shiny. It's got kind of a mottled pattern on it. the grass, the squares are not part of the texture, by the way. That's just the floor of the world kind of being drawn. But if you zoom really close in, you can see like there's actually quite a lot of detail on the grass. And if you zoom out, you can see it doesn't really repeat, you know. It's actually pretty good. As you zoom out further, like there's no like obvious like tiling and repeating. Because that's how things used to look back in my day, back in the 90s. People wouldn't do materials like this. They would have a texture. And so if you go into the starter content, into textures, what is a texture? A texture is a picture. Okay? And so if you just put a texture onto a surface, it will just apply a 2D. Do you see that? Like, it is just a 2D image that will just appear on the wall. And there is no depth to it. It's not shiny. It's not coming up out of the wall or anything like that. It's kind of stretched all the hell here. The bricks are a little bit too big to be realistic looking. Don't really like it. Yeah, it's fine. If we put, you know, the cobblestone pattern on it, you can just see it. Yeah, it's just a picture of cobblestones. Okay. So, we're going to do better than textures. We're going to do something called a material. So, we are going to start off with like, why does Hilton keep trying to spam me? We're going to start off with just a basic, I don't know, cube or something like that. We're going to slap a texture on. Okay. So we're just going to start off with this box here. Okay. And we're going to make a brand new material. I'm just going to walk you through the basics of materials. And then by the end of class today, you're going to be able to go and find resources online from real artists, not me, and import them into Unreal Engine and make really nice looking materials for your projects. Okay? Or you can do hand drawing. That's fine too. If you want to do a stick figure and slap it on the thing here, we can do that. Let me show you how to do that right now. Stick figure me. This is Bill. Oh, wow. Okay. Paste. No. Okay. I'm joking. Okay. I mean, you know, save image. Import. Actually, I don't know if that'll work. It's animated GIF. Here, we'll just do like, we'll do some tag team stuff. There you go. So I drag the image onto there, and then you've got, you know, some fantastic wrestling stuff. Anyway, that's not what I'm here to show you. I will keep that GIF around just in case. All right. So yeah, if you want to just slap an image on something, it's pretty easy. Just import the picture and slap it on, and it'll just appear on the wall. It's fine. His name is John Cena. You can't see me now. All right. So what we're going to do is we're going to make our own material. So if you right click on just, you know, the content browser down here, if you right click and choose new material like that, you can see it's one of the 4 big things here. New level, new blueprint class, new Niagara system, which I do want to get to this semester. Particle effects are really cool. Real particle effects, not like the canned things we've been doing. So we're going to make a new material. Here we go. All right. So the new material we're going to call test material, because it's going to look terrible, but it'll be educational. All right. So I'm going to apply the test material to the box, and you'll see that there's absolutely nothing there. Cool. That's where we should be. So I'm going to open this up. I'm going to snap it over to here. Actually, let's see here. I'm going to snap that off over here. Snap you over here and there. And I'm going to snap you over here. Okay. So while I'm working on the material, every time I save it, you're going to see this thing update over here. Okay, so you kind of see the changes. This is also a preview node, but this is actually going to show you what it looks like in the world. So over here, what do we got? So we've got a node system, kind of like blueprints, but it's not blueprints. It's not code. What it is each one of these pins are going to have a value computed for them. And then whatever value it ends up with is what's going to appear on the world. These values can either be a single result, like if I were to set the color to like blue, it would apply blue to every pixel on that surface. Or if you have like a 2D thing, like the image, like the tag team wrestler, then it will map the 2D picture to the surface. And so you can either have one color for the entire surface, or you can have like a 2D picture that will repeat over the surface. So let's just start with a single color. So I'm going to drag from the base color out, and I'm going to choose a constant 3 vector. Okay. And a constant 3 vector is color, RGB. Okay, so if you drag that out, choose constant 3 vector, and then double click on the black color picker here, you can drag this up and down and get yourself whatever nice color you like and hit OK. And then hit save. And once it does that, it compiles, and there we go. Then it appears over here. Okay. Double click on the color picker, and we want it to be some sort of like purple, lavender kind of color. Hit save. Saves it. Compiles the shader, and then it's now a nice lavender color over here. Yeah, cool. So you can pick any RGB color you want, and it will appear on the cube. Or you can import a texture like this. If you just drag a picture in, it'll actually do what's called a texture sample. And if you hook that up to the base color, then see, we got back what we had before. All right, and so you can see the dudes right there. The preview mesh is a sphere, but you can set it to a cube. There you go. So that's a better preview for what we're doing right now. Okay, and so you can either have a 2D output to each pin or a 1D output to each pin. Either way, it will work. So I'm going to switch it back to lavender. And then we're going to just go through each one of these pins and explain to you what they do. So metallic is either 0 or 1. So 0 means that it is not metallic. It is a plastic-ish material. And it defaults to plastic. So if you want your thing to be plastic, you don't have to do anything. If you want it to be metallic, drag out from there and choose constant. And just a single constant, not an RGB constant, just a constant. And then down here, bottom left right here, you can set the value of it to be 1. And if you do that, then this thing will turn into a lavender metal. Look at that, huh? Kind of cool, right? Kind of cool. So it's now a metal rather than a plastic. All right. Kind of neat. All right, so specular is how shiny the thing is. Basically, between specular and roughness, you're able to determine sort of how it reflects light. So let me show you what spec highlights is. It's like on a pool. Not helpful. Spec highlight. It's like on a pool ball. There you go. So the more intense the specular highlight, the kind of narrower and brighter the reflection gets like that. That's called a specular highlight right there. And shiny objects tend to have very strong specular highlights. Rough objects tend to have wider and more diffuse ones. Okay. And so if we were to, it defaults to 0.5, which is actually a reasonable value for a lot of things. But we can show you what this will look like. So we'll pick another constant here. And we will set the spec highlight to 0. Why not? And so that means there's no specular highlighting on it whatsoever. And actually, I don't know if it uses that for metal. Let's turn metal off. I think metal doesn't use specular highlighting. Okay. And so this means that there's no shiny spot. And it actually is kind of a weird look. Do you see that? Like, you're kind of expecting the sun to like have some sunspot on it, you know? And without it, it looks like really weird and like artificial, you know? Because materials in real life don't really behave that way. So if we were to set the specular highlight to like 0.8, like a fairly high value, watch what happens here after it compiles. So you see how like it's kind of reflecting the sunlight depending on the angle of the reflection and stuff. It's kind of, the sun's like over there somewhere, right? And then there is something called roughness. Now, roughness is in conjunction with specular. It controls kind of the light qualities of, why are these things not lining up? It bugs me so much. Alignment, align, left. Thank you very much. And so a roughness of 0 is perfectly smooth. It's like a mirror finish. It actually looks quite unrealistic. You see that? It's actually reflecting the grass off of it now. You see that? Like, you can actually see the, the house and the chairs and things like that, because it's so smooth. It's actually working like a mirror. And this is because I have ray tracing on. If you don't have ray tracing on, it probably won't do this. It might do it a little bit. Probably not. Okay. So that is a perfect mirror smooth finish like this. It's a little bit unrealistic. Even if you want something shiny, you're typically going to put like roughness, like maybe at like 0.2, something like that. And then if you watch what happens here, you're not going to get like a perfect reflection anymore. You see that it's kind of like, you can still see the outline of the objects and stuff like that in it, but it's kind of like a little bit more blurry. If you put it at like 0.1, it'll be, again, not quite a mirror, but you're going to kind of get the general outline of things in the, you see that? Like, you can kind of see the house a little bit. It's a little blurry. So in general, like, most objects aren't mirror finished. And then on the other end of the things, if you give it 100% roughness, then it's going to look really weird, because that means it scatters all light randomly in every direction, and it looks very kind of fake and artificial. Like this it just looks like it, I don't know. It just looks super strange. And so, if you want things to be rough, like maybe a 0.7 or something like that, and then you'll get kind of looks kind of like plastic that way. Okay, but I'm going to make mine shiny. I like shiny. Do that. Okay. This one doesn't matter that much. Emissive color is kind of cool. So if you want the thing radiating light, you can do that. So if you want it to like emit light, you can drag this off and do a const 3 vector. And double click color picker, you can make it like red. Okay. And if you do this, then you'll actually see the thing like emitting red down here, because I got ray tracing on. Let's bring it next to, it's actually not bright enough, I think, to do very much. Yeah, there you go. You see that? So it's actually it's like a headlight on a car, right? It's actually radiating red light, but it's not very strong. And so you can actually bring the red levels up over 1. So if you want 100 times brighter, you can set the red to 100, and then it will radiate 100 times max red on it, and it will look like the Eye of Sauron, kind of thing. And so you can see the red is just glowing like crazy. This is also, I think it requires ray tracing to be on. If not, Unreal Engine 5 requires Lumen for this really to look good. It is awesome. Yeah, it's super cool, and it does it in real time. So you can have these objects moving around, just like glowing, like you got iron coming out of the forge or something like that, and the world will dynamically update its lighting based on the emissive light. And you see the spec highlight over here on that guy. That's a specular highlight from that light source right there, and you can see the light kind of like coming off and hitting all these things here. It's pretty cool stuff. Now, what if we have the base color be WF? I don't know. Nothing, you can't even see it. Okay. Turn the light down a little bit because it's so bright we can't see the tag team match. There we go. All right. I wonder if we can do this. We're going to multiply that by 100. So we're going to have the tag team glowing with the strength of 1,000 stars. I've never done this before, by the way. It's amusing, you know. There we go. So yeah, so the stars of the WWE, sorry, are radiating light. Yeah, true story. Okay, so yeah, just let it glow purple. Nice soft purple glow. Okay, normal. Now this is getting into like real life kind of stuff. So let's talk about it a little bit. So video games are limited by how many triangles they can draw on the screen. Okay. So this cube here, every face of the cube is probably 2 triangles, right? Because a square, you can cut a square in half and have a triangle. Everything in video games, mostly, like 99% of the things you see in a video game are going to be a triangle, okay? When you get down to it. You can't really see it right now, but it's a triangle. If you switch it over into wireframe mode, you can see that the face of the cube here. You can see the diagonal there. And you can see the other triangles that go into this cube here. You can see this guy here is actually quite a lot of triangles. The sky is a lot of triangles. The train is a lot of triangles. The cube here, not too bad. Right. As far as these things go. So every video card has a limit to how many triangles it can draw on the screen at once. And so a very common technique that we use, let me turn off the emissive, and let me just make this purple, is to do something called a normal map. So normal map, the normal of a surface is a vector perpendicular to the surface. So the normal of my hand, if this is a plane, is this pencil coming out here. And that's used to determine how light reflects off the surface. If you think about a mirror, right? Light hits a mirror like this, and then it bounces off like that, right? It reflects around the normal. The normal is like sticking out of it. So it comes in, it bounces off the normal, and it goes that way. So that controls essentially how light reflects. I've probably got a picture of it around here somewhere. So yeah, direction lights we talked about before. Spotlights we talked about. Okay. So yeah, so here is. So specular reflection is when it reflects off like a mirror. Diffuse reflection or roughness is when light hits it and then it scatters in different directions. So the old way of doing things would have a specular highlight, a diffuse, and an ambient. Ambient is just universal coloring. So light hits, and some of it goes towards the specular reflection like a mirror. Some of it reflects outwards in a diffuse reflection. Now, this is what, this is how I was doing coding in the late 90s, putting lights on teapots and things like that. Okay, so emissive, let's see here. I guess this is the closest thing we have. So the normal of the surface here is pointed straight up, okay? So, sorry. So we have the surface here, the normal is pointed straight up, and so the light that comes in, if it's a mirror, is going to reflect around that straight up normal and bounce off that way. So, what is a normal map? A normal map can be used to simulate cracks and grooves and wear and tear and little bumps on a surface and things like that without needing any more triangles. Okay, that's really important because triangles are essentially the limit of how fast your game can render. And so if you have a lot of triangles, your game's going to render very slowly. And so doing things like if you see the top of my cup here, you see how there's all these like grooves right here along the surface, right there? Can you guys see that? Is that coming through? There's like all these like little, like I don't know if you can hear it, right? There's like this little groove surface here. There's absolutely no reason for me to draw that as a triangle. It's just a little detail on a little cup in the game. What I can do is simulate it using a normal map. So the normal map will say, hey, this area here is pointed straight up. The normal on this one is a little bit this way. The normal on this one's a little bit this way. And it can simulate detail by cheating, essentially. Okay, so let me show you what I'm talking about here. So if I were to bring in a normal map for like bricks, all the normal maps end with _n, right? So if I bring in a brick normal map and drag that in, I'll get a texture sample. And then if I hook that up to the normal map here, what that's going to do is it will make my cube look like it is a brick surface. There's no pictures of bricks or anything like that. All of this is just simulated by the fact that light is reflecting off the different points on the cube in different ways. And so some areas are straight up and they just reflect light like a mirror. Some of them are pretending to be at an angle this way. Some of them are pretending to be at an angle this way. And if you look at it, it looks like I've got all this detail on my surface. Now this thing doesn't have any actual indentations on it. There's no triangle cost to any of this. It's just simply like this part of the raised surface of the brick is reflecting light one way. And if I, do you see this right here? Like there's like that little strip of like white light there. If I walk around it to this side, you see how it's not lit up anymore? It's because my camera's pointing the other way now. And so this is a completely flat surface. And it's just all a lie. It's just all a giant gargantuan lie. But it looks pretty darn good until, like if I go right, let me lower my camera speed. Camera speed, I'm gonna have to go down to 1 on this one, I think. If I go right to the side over here, you see that? There's no actual raised brick or grooves in it. But you have to like go right up to the side and kind of like really like, you know, slide along the surface, and you can see there is absolutely no, you see it's just a like there's no detail on that whatsoever. But from, you know, the front, like that, like do you see that? Like it's reflecting light off the different bricks, like, you know, in different ways. It's reflecting the clouds in the sky. And all of those reflections are just caused by this normal map saying which parts are flat, which parts are curved this way, which parts are curved that way. If I were to switch it out with like this bush here. Let's delete that. This is the normal map from a bush. I have no idea how this is going to look. So this is a completely flat surface, right? And it looks like, you know, it looks like there's raised and curved areas on it with absolutely no cost. There's really, I mean, there's a small cost using normal map, but isn't that cool? It's not so cool. Like it looks, you know, I mean, it doesn't look real because I made it purple. You know, I could even, you know, hook up the tag team guys to it, right? And then use a normal map for like, I don't know, rocks. Yeah, let's do that. Pull in some rocks, normal maps. Save. And so now it's going to look like the tag team wrestlers are on a rocky surface. Isn't that cool? So the different, you know, bits of, you know, the rocky surface are reflecting light, you know, as if it was bumpy, right? So you'll sometimes see these things called bump maps. Bump maps are slightly different than a normal map, but yeah, basically you can think of it as like adding bumpiness to a surface. Very cool, gamers. Do you guys like that? I mean, I've taught this class for a while, and I've used normal maps and bump maps for, you know, decades, but I still think this is pretty darn cool. That you can just be like, yeah, you know, before it just looked like a really tacky, flat cube with like, you know, 6 pictures on it. Now it actually looks like, all right, you know what I mean? Like, it looks like somebody made a rocky surface and like kind of spray painted, you know, a tag team match on it. Maybe if we add it to a bigger surface, we'll add it to the wall over here. There you go. You see that? I mean, that's kind of cool. I don't know. You tell me. And that's just from adding a normal map, right? It's just reflecting off. Now it looks very shiny, right? Because I have the I have it set to be very specky, and I can turn that down. I can turn up the roughness, because if it's stone, it should be at least, I don't know, like 4 at least, probably. Let's save that. And so we'll cut down on like kind of the, because it kind of looks like it has a plastic clear coat on it. There we go. That's a little better now. So now, you know, you can still see the mottled, you know, stoneness, but it doesn't look like it has a plastic sheen to it so much. Unless that's what you want. So the camera speed back up to 3. And so there you go. So that looks like a, you know, like a mural on the side of a building, right? Looks way better than just what we had before, right? Cool. This new discovery won't make my games look like they were made and distributed by Wish anymore. Well, it depends what you're going for. If you want them to make... It really depends what you want. Okay. So let's see here. Let's put it back on purple. I kind of like this stone. Normal map will probably keep that. Yeah, that looks pretty cool. All right. Quadruple A game. Sorry. Yeah. Now, if you want to actually make it stone, let's see. Under textures, which one was this? Rocky and switch Rocky. Is that it? I don't have a... There's no albedo for it? Interesting. Oh. There's only a normal map. Normally these things come with like a picture and then a corresponding normal map. But this one just has a normal map, I guess. I don't know. So either way, looks pretty cool. This looks like, I don't know, somebody's made a stucco, like a spray painted a stucco house or something. Looks pretty rad, honestly. Don't care. World position offset. So if you want it to actually adjust the geometry, you can do so. I don't think it's actually that important, so I'm not going to show you how to do that. You can look up how to do that, but that would actually cause the mesh to deform up and down. So if you look at it from the side, you'd see the bricks raising up off the surface. It has a performance cost, and it doesn't really help that much, so it doesn't matter. Ambient occlusion is kind of cool. I don't know if I have any AO. Here, I don't have any demos of it. So when we go to show you how to make one of these things for realsies, so ambient occlusion. So ambient occlusion, have you guys seen this in video games before? Like it'll talk about like SSAO and like HBAO and things like that. Like you can see those in your detail settings and stuff like that. So let me just go to the cube and I'll just do that. I actually kind of might make it a little bit shinier. I did kind of like the shiny. Up the spec, down the roughness. Make it look. Yeah, you see that? How there's more light reflecting off it now. I kind of like that. Okay. Kind of like it's a freshly painted coat. Maybe. Okay, so what ambient occlusion is, and let me save everything in case we crash. As always. So ambient occlusion is the notion of self-shadowing. So, like your nose shadows your face and things like that. This is a great example of it. So the way that it's done, at least it was done originally, was at every point on the surfaces of the grapes and things like that here, it would do like a little semicircle, hemisphere, and it would see how many of, if it shoots rays out for about 1 centimeter, how many of those things are getting occluded, blocked, right? And so the more of them that get blocked, it darkens it. And so what it does is it adds like that effect you can see right here at the bottom of the banana, where it adds like a shadow around it. It adds shadows in the creases of the grapes here. Like in any groove or something like that, most of the rays coming out of it are going to get blocked, and so it darkens it. And so it adds a nice little like bit of realism to yeah, that's good. That's a good example. right? So like if you just light everything directly, you know, all this stuff is just lit, you know. But here you can see on the edges here, they're darker, like kind of like in real life. And you can see the grooves here are darkened. Yeah, the grooves down here are darkened. And so it's not actually getting lit from any particular light. It's actually just simulating that like cracks and edges and things like that tend to be darker because they don't get a lot of light. And so, do you guys understand? So, you know, it looks in general, ambient occlusion looks better. It's not exactly realistic. Like it's sort of simulating ray tracing, kind of. It's kind of simulating ray tracing. If you had full ray tracing, you wouldn't need it. You know, like on here, in the corners here, you can see it's darker. So this is like you can actually switch into like ambient occlusion view, and it's showing all the areas that are being darkened by ambient occlusion, like the areas between the pipes here, things like that. Okay, so let's talk about making a real material. Okay, so there's a lot of great websites out there for game developers. Game development is like a big industry, right? And so there's a lot of places out there that will give you a lot of free stuff and then try and upsell you on, you know, stuff that's not free. Some of the best sources of free, yeah, let's do the free stuff. Yeah, I've occasionally had students spend like money on their class projects. I'm kind of like, you know, don't do that. You know, like, I mean, if you want to, I can't stop you. You know, but there's a lot of free stuff out there. So Polyhaven is a site that I like. There's also a lot of free assets just on the Unreal Marketplace. So if you go over to the Marketplace and you go to, whenever you load, free Megascans. This is a whole bunch of very realistic materials that you could import and use into Unreal Engine. Force floors and, you know, they have stuff for everything. But I'm going to kind of show you this website called Polyhaven. And Polyhaven has a great library of textures that are high resolution. It browses textures. And what's nice about it is it'll actually, it's in Blender, no, go away. Okay. Early access. Oh, interesting. So that's how they get you to pay for it. So you Patreon them and then you get access to these things early. That's kind of acceptable, I guess. Okay, and so you can kind of scroll around and you just kind of look at what these different materials look like. And so maybe, I don't know. What do you guys think? Rock boulder, coastal land, forest leaves, brick wall. What do you think? Maybe square floor? Maybe I can put that inside of my postmodern office building. Does that seem reasonable? Or we can put this on a picnic table, probably. So we need to choose from. I know. But your homework assignment's going to be this. So your homework assignment's going to be to go to Polyhaven and you're going to import. You're going to go through the process I'm about to show you, and put it into your world. And so you can sort by different categories and things like that. I don't know, something mossy. Okay, brown mud leaves like that. I don't know where I'd put that in my world right now. Great. Floor pavement. Bricks. I can print the bricks on the building. Leather. You can put that on like, you know, furniture. Denim fabric. Palm tree. Mossy rock. That looks pretty. That actually looks pretty cool. I guess I could put it on the platforms. We'll see how that looks. Okay. Okay. So I'm gonna grab the square floor too because I kind of like the look of this. This looks kind of pretty. You see how there's like all the different detail on the different tiles and stuff like that. It's kind of cool. I like it. So, okay. So we are going to download this somehow. Where are you? Remove ads. Sponsored by. Where is? Okay, there we go. And so I'm going to download the 4K version. If you want to save hard drive space, you can go with the 1K version. Usually when I'm doing game development, I download the highest quality setting possible. But here's 72 megs, and this one is 240 megs. So there's quite a bit of difference in size as you go up in detail settings. So I'm just going to go with 4K. Like, that's a quarter gig per texture. You know what I mean? Like, you burn through your hard drive real fast when you work with really high res textures. So I'm just going to go with 4K for now, and I'm going to go to zip, and I'm going to do blend. No. AO rough metal, diffuse, displacement, and normal map. And the normal map, I think, is DirectX and Unreal Engine. Use DirectX or OpenGL maps. Because, of course, DirectX didn't follow the same coordinate system for who knows what reason. Doesn't help. Not helpful. I think it's DirectX, if I remember correctly. Okay. So we'll just leave it on the default. Okay. And so what we're going to be downloading here is a series of pictures. We're going to download a total of 4 pictures. And one of the pictures contains the color, which is called diffuse. That's the equivalent of this thing here, the picture, right? It's called diffuse, sometimes called albedo, sometimes called base color. All the same thing, essentially. The displacement map is how far up and down it is. I don't know if we're going to be using that. Probably turn that off, I guess. I'm not going to be going over that. And then the big ones are the color and the normal map. Those are the two things that if you just import those two things, it'll look pretty good. Now, there's also ambient occlusion, which we just talked about. That's going to add shadowing into the creases and stuff like that. It'll make it look good. There's also something called a roughness map, which shows you how rough each spot is. And so like the grouting is going to be rougher than the smooth tiles. And there's also something called metallic, which is probably going to be false for everything. But here's something cool. So rather than downloading the ambient occlusion and the roughness and the metal separately, you can actually combine them all into just one texture. Because there is a red, a green, and a blue channel in a texture, RGB. Ambient occlusion is monochrome, roughness is monochrome, and metal is monochrome. Basically, at each point, how rough is it? White, super rough, black, super shiny. And so basically all 3 of these things get combined into one picture. And the order in which they are listed here is which color channel they are. So the ambient occlusion is going to be in the red channel, the roughness is going to be in the green channel, and the metal is going to be in the blue channel. So let me show you what that looks like. So let's go ahead and download it here. Square floor. And we'll come up here and download a 4K version of EU as well. Rough metal, diffuse, displacement. Again, we don't need you really. And normal map. Cool. And we'll download EU as well here. Okay. So thank you, Polyhaven. Yes, I want to leave. Okay. All right. So I'm just gonna bail out of test material here, and I'm gonna make a new material. Because I kind of like this one. I'm probably going to keep this for the duration of the semester. So, there you go. Okay, you're welcome. So, it's hard, yeah, like, who can get upset about that, right? All right, so let's go back into the build directory, or whatever you call it. And I'm going to actually make a new folder inside of here called materials. And the reason why I'm making a folder for materials is because when you start importing materials, you're going to start importing a lot of files. When you start doing animations, you're going to import a lot of files for all the different animations. And so, and I probably should have one for, for sounds, art, all that kind of stuff. Once it gets kind of out of control, I store them in folders. But materials, you're going to see what I mean. So I'm going to import. Oh, it's currently zipped. So I'm going to go to Professor Kearney's face, the guy in the air. That was the plan, actually. So the reason why I have this on my computer is because at the start of classes at Fresno State, I sent out a note to all the students saying, hey, my friend, Professor Lobachevsky from the math department, is going to be guest lecturing on the first day of class. So, be nice to him, right? And so it was, of course, me. So I had this thing here, and I was going to have Kearney, and Lobachevsky, and my face was going to be on Lobachevsky's, and Kearney was going to be John Carmack's face. And I have all these tag team images, Kearney and Lobachevsky tagging out, things like that. But nobody from CSI 1 joined the Discord. There's only 3 people from CSI 1 on Discord, so I was who cares? But I got it on my disk. Anyway. So, but yeah, that was originally the plan. So here we go. Mossy Rock. We are going to extract to a folder. Square Floor. We are going to extract to a folder. And then I'm going to just drag those folders into here. That works. Okay. Shoot, it didn't work. What happened here? Mouse Rock 4K textures. TX. They didn't download as PNGs. Weird. Yeah, I must have had the wrong format or something on them. Okay, well, let's not do Mossy Rock then. Let's just do Square Floor. So yeah, see, for Square Floor, I got 4 different PNGs, but for the other one, it didn't. Only one of them was a PNG. It's kind of weird. All right, so let me drag them over here. Make sure you download them in PNG format. We'll just work with the floor for now. Okay. File, save all. So we've got here a picture of the floor. We've got a normal map. We got a diffuse map. Diffuse map is the picture. Displacement map, if we care about the up and down, which we don't. And then arm. So the name of this is arm. Anytime you have something kind of weird like that, that means it's a multi-channel image. So remember what I said, ambient occlusion is monochrome, roughness is monochrome, and metallic is monochrome. And so ARM means the first channel is ambient occlusion, red is ambient occlusion, green is roughness, and blue is metallic. Okay, so let's make a new material using these professional assets. So right click, new material, and this is going to be called Square Floor Mat. Open it up, and let's snap this off here, and snap you over there. And we will throw Square Floor Mat on the floor over here. And we will snap you over here, and there we go. Okay, so let's do this. Here is the process. Okay, so this is what I do. When I'm actually building a game, I find free assets, and a lot of times you have to build the materials yourselves. Okay, so you find pictures of things, and you got to assemble the material. And this is your homework. This is the steps you're gonna have to go through. Okay, so I've created a new material, and now I'm gonna start hooking things up. So the diffuse is the base color, so I drag it in here. This is my texture sample. It makes it up for me automatically. So that's why I kind of like having the split screen thing up like this, in part because I can save it, and then after it compiles the shader, you'll see it appear on the floor over here. So which is a little bit more helpful than looking at kind of a sphere, So you see right now, it's already all right. It's probably a little bit too big. Those tiles, I think, are supposed to be a little bit smaller. But you can see how it's very flat. You see how that without a normal map, it's just reflecting. It looks like somebody took a picture of tiles and just wallpapered it on the floor, right? Do you guys see that? If I put it up on the wall here, it's just completely flat. It just looks like one of those pictures that people just glue to their walls. Do you see that? There's no depth to it, right? Yeah, no. You see what I mean? It's just completely planar. Okay. Okay, so we got the floor there. Metallic is going to be false. This isn't a metal floor. Specular. Okay. Normal map. Okay, let's do the normal map first. That'll be the biggest win for us. So we'll drag in the normal map. So I just drag it in like that. Look up the normal here. Hit save. And then watch the grooves. Watch what happens here. You see that? Pretty cool. If I slap it on the wall over here, now, yeah, you can see the light reflecting off the different grooves, right? Yeah. Like basically just between the color and the normal map, like that's, you know, half the battle. Okay. So what else we got here? We got displacement. Like I said, I'm not going to worry about that. If you double click on one of these things, you can see these are the areas that are raised up and lowered down. I'm not going to worry about it. It adds a lot of slowdown to your world, and you usually don't need the fidelity. Like, yeah, okay, sure, it's actually going to bump the things up, but usually it's just not worth the price. Okay, so the other thing we need to bring in then, if we don't care about displacement, is we're going to bring in arm. Okay, so arm is, if you remember, ambient occlusion, roughness, and metallic. So you see here, like before I was just hooking up the RGB, right? In the RGB. For this, I'm going to split off the red. The red is going to go into ambient occlusion. Remember how I said the first channel is red? Double click on this. Double click on this. It looks like weird. It looks like some weird Halloween something. But watch. If I turn off these channels up here, this is the red channel. This is the ambient occlusion channel. So you can see that the areas in the grooves are darker, right? And so if we apply the ambient occlusion to the world, you'll see little darkness appear in the cracks. So let me close out of here. And if you look at the green channel is roughness. So you can see some of the areas are going to be rougher than others. Like the grout is rougher, right? If that makes sense. And some areas are going to be very shiny on the tile. And then the, what was the other one? Metallic. Nothing's metallic. Zero metallic across the board here. Okay, so let's go back here. And we could hook up the metallic to blue. Metallic defaults to 0 anyway, so who cares? Right. And so we have ambient occlusion. So let me, yeah, it's very dark in here. Oh, wow. Let me, make it a little brighter, I guess. So I'm now going to save this, and you're going to see the ambient occlusion kick in. So pay attention, especially to the cracks in here. It gets a little bit darker, maybe. All right. And so if I delete the ambient occlusion and save, just pay attention to, like, I don't know. I can't even see, really. It is also kind of dark. So that's the ambient occlusion, and then the green is roughness, which is covered by my face. Okay. So green is going to go up into roughness like that. Save, and then you should see some of the areas become shinier and some of the areas become rougher. See that? Kind of cool. What do you think? So, yeah, it's super shiny now, actually. Probably a little too shiny for me, honestly, if I had to do it. This looks like a very slippery floor, if you ask me. So I would probably actually reduce the shininess a little bit. So I can do that if I drag out from the roughness here. You can do multiply. And I'm going to multiply it by 0.5. So if I save, oh, it's not hooked up. If I save that into roughness, then this thing will become a lot rougher. So watch carefully as it compiles. And so you see that? Like it went from being like super shiny to just like kind of shiny. Actually, sorry, it's actually way shinier now. Sorry, I made the roughness less. I didn't make it bigger. That was my bad. Yeah, so it's actually like, yeah, super shiny now. Sorry. Yeah, let's do that the opposite way. Let's double the roughness. If you double the roughness, then it will become less shiny. Okay, let's try that. There we go. All right, that's more what I had in mind for a tile floor. So it doesn't look like something you're going to slip on, right? It's still reflecting light, but it doesn't look like it's wet. You know, it should probably distract people a little bit. Now, what do we got? We got 10 minutes left. So there's one other thing I want to show you, which is you can adjust the tiling factor on this. So you see how the image will by like default stretch to cover the entire surface. Here, like these tiles are like, you know, it doesn't look terrible, right? It doesn't look terrible. They're still like probably a little bit bigger than the user was intending. So there's something called UV mapping. So UV map is how you choose how the texture gets mapped to the surface. And so by default, it's just a one-to-one mapping, right? So location 0, 0 on the picture goes onto location 0, 0 on the floor. And location 1, 1 goes to 1, 1, and it just stretches the thing over the whole thing. And that can look bad. Like if I were to put out a cube here and like stretch it way out in one direction and put the floor on it, you see how it's like super like janky looking, like it's like it doesn't even look good, right? It's just super like, because the top left corner of the picture is right here, and the bottom right corner of the picture is right here, and so it just stretches the thing out, right? So my eyes, yeah, when you went outside, right, we were in the dark for a while. So this is not great. And so you can do something called UV mapping, which will allow you to adjust the tiling size in each of the dimensions. So we could do what's called a text coord. Texture coordinate. And you can drop those into the UV input here. That. And by default, it doesn't do anything. It's 1, 1. But like, let's say that I want this thing to tile, I don't know, what's the scale on this? 20, okay. So the cube here is scaled out 20 times. So I could set, was it the U? Let's try that. I don't know what the axis is. So I can set the horizontal tiling to 20. And then, oops, that was, oh, actually, yeah, no, that was perfect. That actually made it work exactly right. You see that? So now the texture draws 20 of its pictures in the horizontal direction, but only 1 in the vertical direction. So this actually looks pretty good, right? So we now have the thing scaled properly to the surface. You know, and the width of it is still 1, so that works. But we're gonna have a problem over here. The problem over here is that we are using the same tiling rate on this square surface here. And so everything has now been smashed down 20 times. And so there's a couple different ways of solving this. The best way of doing it is using a texture parameter, where you can manually adjust the tiling factors on it. Or you can just not apply it on super scaled surfaces like that. So one or the other. So I'm just going to change this to be like 4 and 4. Save it. And you know, later on, we're going to learn how to do texture parameters. But for now, you can just see over here that now that I have set the scaling to 4, it is going to draw the picture 4 times on the floor rather than once. You can see each of the individual floor tiles are now noticeably smaller than before. Yeah. And so whereas before those things were like, I don't know, yay big, now they're like this big. Okay. And if I wanted, I could make it 10 and 10. And now the individual tiles are going to be like this big. Right? So you can adjust that. We got a little floor mosaic thing going on here. Now these things are rectangles, which makes me suspect this is not actually square. Yes, it's not exactly square. So let's put it at 10.25 and 9.5. That's the actual size. I just pulled that up from the details panel here. So if you set the tiling to the scaling of the object, then it gets exactly correct. So now we've got exactly square tiles here, and so it's looking pretty good too. Okay, so that is that. Okay, kind of like it. Let's save all. Close you out. Let's play the game. See what we got here. So we've got our time remaining kind of thing here. Sprint. Oh no, I'm gonna die. There you go. Okay. Completed that. Kill you. We got the tag team up there. Kill you. Kill you. Kill you. Okay. And now we've got this really cool looking floor. Yeah. This isn't even the high-res version, right? I downloaded the 4K version. The high-res would have even more detail on it than before. But, you know, your hard drives will thank me. 8K resolution's a little bit overkill at this point in technology. I tend to download the 8K so that I can downscale them as needed. It's a lot harder to upscale things to get more detail. It's a lot easier to downscale to get less detail. But I think 4K is more than sufficient for now. Yeah. So let me pull up Polyhaven one more time, and maybe I can figure out what I did wrong with the grass thing here. Polyhaven, textures. What was it? Terrain, maybe rock. Coastal sand rocks. Which was the one that was like. And so you can see anytime it's not perfectly like, you know, circular, a perfect sphere, that means they have a displacement on it, and the displacement map will actually push the things up. No, okay, let's just try and scroll down. No. This one, Mossy Rock. Okay. So here's Mossy Rock, and I'm going to go over here, 4K, zip download. Yeah, they're set to PNGs. Weird. But they didn't download as a PNG. It's kind of strange. All right. Try downloading it again. Mossy Rock, download. Open. Textures. Yeah, see, they're not coming through as PNGs. I think it's just a bug on their side then. I don't know. 4K. Yeah, I don't know. So pick something else, I guess. I don't know. Yeah. So I clicked on PNG, but it didn't give us a PNG. So I don't know what to do. So that's basically it for today. So with the knowledge you have from today, you should be able to make, you know, things that don't look like plastic, you know, monochrome plastic surfaces anymore. You know, fairly nice things like this, or fairly, I don't know what the word is for this. I wouldn't call it nice exactly, but you know, there you go. So, yeah, it's got a little bit more realism than if it was just a flat, you know, like picture slapped on the side. Okay. So that's it for today. Any questions about it? Your job is to go onto Polyhaven and construct a nice looking material using the diffuse base color, using the normal map. Those are the two big ones. And then ambient occlusion, roughness, and metallic as well. Don't worry about displacement. Like I said, it's usually not worth it. Okay. You guys cool? Kind of fun, right? Like, it's kind of neat. Like, you don't have to be an artist, you know? You can, like, all of these things, like, you can, like, mess with. And, you know, you can, you know, open this in Photoshop and mess with it if you want. The amount that I mess with it usually involves doing something like the multiplication node. Where was that? like this, like, so this is grabbing the roughness, and then I'm multiplying all the values by 2. So it makes everything twice as rough as before. That's the level of, like, you know, art I go to, where I like take existing stuff and kind of like tweak it a little bit to kind of match my notion of what things should look like. But that is more or less what your homework's going to look like. So your material is basically going to have one texture feeding into the base color, one texture feeding into the normal, and then one feeding into ambient occlusion and roughness. And maybe metallic if, like, some of the areas in the map are metallic and some aren't. If it's all not metallic, just don't. You could hook it up. Like, you could do this like that, hooking up blue to metallic. But since it's all black anyway, no point. I didn't know how much you can do with materials, even though you just import it. And yeah, that's it. Yeah, so it's yeah, and there's a lot more. Like, we can talk about lerping, and like I said, next time we're gonna talk about dynamic materials, which is super cool. So this is kind of the basics, and I kind of want to stop here before we get on to more advanced material stuff. Okay, so that is that. Yeah, Disney not hand animating anything. It's kind of sad. I agree. All right, that's our class. Peace out, everyone.